Welcome to this deep dive into designing a scalable and robust system like Stack Overflow. In today's session, we'll dissect the architecture and underlying principles that power one of the internet's most vital knowledge-sharing platforms for developers. Stack Overflow, with its vast community and immense traffic, presents a fascinating challenge for system designers, touching upon almost every aspect of distributed systems. We'll explore how to handle millions of users, billions of queries, and a constantly evolving content base, ensuring high availability, low latency, and data consistency. This journey will cover everything from initial functional requirements to advanced scaling techniques and future enhancements, providing a comprehensive blueprint for tackling similar large-scale system design problems. Let's begin our exploration into building a resilient and high-performing platform. Before diving into the technical architecture, we must first understand the core functionalities Stack Overflow offers. At its heart, users need to be able to ask questions and provide answers, forming the fundamental Q&A interaction. This includes the ability to format code snippets, embed images, and generally enrich their contributions. Beyond the basic interaction, the platform relies heavily on community moderation through upvoting and downvoting answers and questions, which also impacts user reputation. Users must also be able to add comments to posts for clarification or minor suggestions. Crucially, a robust search functionality, supported by a system of tags, allows users to efficiently find relevant information among millions of posts. Finally, user profiles are essential for tracking contributions, reputation, and personalized settings. Beyond what the system does, we need to consider how well it performs. Non-functional requirements are crucial for a platform of Stack Overflow scale. High availability is paramount. The site must be accessible nearly 24/7, given its global user base. Low latency is also critical, particularly for read operations like searching and viewing questions, to ensure a smooth user experience. The system must be highly scalable, capable of handling rapid user growth and traffic spikes without degradation. Data consistency is vital for maintaining integrity, especially with voting and reputation systems. For capacity estimation, let's consider a massive user base, potentially over 100 million monthly active users, generating around 100,000 new questions and several 100,000 answers daily. This volume implies significant storage and processing demands, which directly influences our design decisions. Let's outline the high-level architecture. At the forefront, a load balancer distributes incoming user requests across multiple web servers, ensuring no single server is overwhelmed and providing fault tolerance. These web servers, often acting as API gateways, then forward requests to application servers responsible for business logic execution, such as processing user authentication, creating posts, or updating profiles. For data persistence, a robust database system is essential, likely a relational database due to the structured nature of Q&A content and relationships. To enhance performance and reduce database load, a caching layer sits in front of the database, storing frequently accessed data. Finally, a dedicated search engine, separate from the primary database, handles complex full-text search queries efficiently, providing fast and relevant results to users. For the detailed design, let's start with the data model, which is fundamental to how information is stored and retrieved. We'll need a user table to store user credentials and reputation, containing fields like ID, name, email, and reputation score. For questions, a question table would include ID, title, body, user ID, foreign key to user, tags, and score. Similarly, an answer table would store ID, body, question ID, foreign key to question, user ID, and score. A separate vote table tracks ID, user ID, post ID, polymorphic foreign key for question or answer, and type, upvote, downvote. These tables are interconnected through foreign keys, representing the relationships. Complementing this, a set of RESTful APIs would expose these functionalities, such as post/questions to create a new question, get/question/ID to retrieve a specific question, post/answers to add an answer, and post/votes to register votes. For search functionality, we move beyond a traditional relational database which isn't optimized for full-text searches across vast amounts of dynamic content. A dedicated search engine like Elasticsearch or Apache Solr is ideal here. These systems index all question and answer text, tags, and even user data, allowing for complex queries, relevant scoring, and rapid retrieval. When a user searches, the query goes directly to this search cluster, returning results in milliseconds. Complementing search, caching is absolutely critical for performance. We can use an in-memory store like Redis or Memcached to cache hot data, frequently accessed questions, popular tags, user profiles, or even search results. Implementing a robust cache invalidation strategy, such as time to live (TTL) or event-driven invalidation, ensures data freshness while minimizing database hits for repeat requests. This combination significantly reduces latency and database load. The voting and reputation system is a cornerstone of Stack Overflow's community-driven quality control. When a user casts a vote, we can process this asynchronously to avoid blocking the user interface. The vote is initially recorded in a message queue, like Apache Kafka or RabbitMQ, and then picked up by a dedicated vote processor service. This service updates the vote table, increments or decrements the score on the associated question or answer table, and then, crucially, triggers an update to the user's reputation. Reputation calculation can be a resource-intensive task, so it's often handled in a batch process or with eventual consistency, ensuring accuracy without real-time overhead. We must also implement mechanisms to prevent duplicate votes from the same user on the same post, ensuring data integrity and fairness in the system. This asynchronous, eventually consistent approach helps manage the load effectively. As Stack Overflow grows, scaling becomes a continuous challenge. A common bottleneck is the database, especially with heavy read and write loads. To overcome this, we can implement database sharding or partitioning, distributing data across multiple database instances based on a shard key, e.g., question ID range or hash. For read-heavy operations, read replicas are essential, allowing us to offload query traffic from the primary database. Static assets like images, CSS, and JavaScript files can be served from a content delivery network, CDN, significantly reducing latency for global users and offloading traffic from our web servers. Message queues, as mentioned earlier for voting, are vital for asynchronous tasks like sending emails, processing reputation updates, or generating search index updates, decoupling services and improving responsiveness. Ultimately, adopting a microservices architecture can break down the monolithic application into smaller, independently deployable services, enhancing scalability and maintainability. Beyond the core functionalities, a platform like Stack Overflow can incorporate several advanced features and enhancements. Real-time notifications, powered by WebSockets, can immediately alert users about new answers, comments, or mentions, fostering greater engagement. Robust moderation tools are essential for community management, allowing human moderators and automated systems to handle spam, abuse, and ensure content quality efficiently. An activity feed system could track user actions and display relevant updates from followed tags or users, creating a more personalized experience. Furthermore, leveraging machine learning for recommendations can suggest relevant questions, answers, or even users to follow based on browsing history and expertise, improving content discovery. Lastly, internationalization and localization would expand the platform's reach to a global audience, allowing content in multiple languages and adapting to cultural nuances. We've journeyed through the intricate process of designing Stack Overflow, from its fundamental requirements to sophisticated scaling techniques. The key takeaway is that system design is an iterative process, continuously refined based on user feedback, traffic patterns, and evolving technology. Prioritizing non-functional requirements like scalability, availability, and consistency from the outset is paramount for any large-scale system. We identified core components such as the database, caching layer, search engine, and load balancer as essential building blocks. Critical scaling strategies include database sharding, leveraging read replicas, utilizing a CDN for static assets, and implementing message queues for asynchronous processing. Ultimately, a successful system design is about making informed trade-offs and anticipating future growth, always striving for continuous improvement and adaptability. This systematic approach ensures a robust, performant, and maintainable platform.